Welcome to our exploration of the alkaline earth metals, the fascinating group 2 elements of the periodic table. These reactive metals include well-known elements like calcium and magnesium, which play crucial roles in both nature and industry. The alkaline earth metals occupy the second column of the periodic table and share many common properties that make them unique and important for various applications in our daily lives. Group 2 consists of 6 metallic elements. Starting from the top, we have beryllium with atomic number 4, followed by magnesium at atomic number 12. Next is calcium at atomic number 20, then strontium at 38, barium at 56, and finally radium at atomic number 88. All 6 of these elements share similar chemical properties because they have the same number of valence electrons in their outermost shell. This similarity in electron configuration leads to predictable patterns in their behavior and reactivity. The key to understanding alkaline earth metals lies in their electron configuration. Beryllium has the configuration helium core plus 2s squared. Magnesium follows with neon core plus 3s squared. Calcium has argon core plus 4s squared, while strontium has krypton core plus 5s squared. Notice the pattern here. Every single group 2 element has exactly 2 electrons in their outermost s orbital. This consistent pattern of having 2 valence electrons is what gives all alkaline earth metals their similar chemical properties and explains why they behave so predictably in chemical reactions. Alkaline earth metals share several distinctive physical characteristics. They appear as shiny, silvery white metallic solids at room temperature, giving them a lustrous appearance. In terms of hardness, they are softer than most transition metals, but noticeably harder than their neighbors in Group 1, the alkali metals. These elements are good conductors of both electricity and heat, making them useful in various applications. Their melting points are generally higher than alkali metals, though the melting point decreases as you move down the group from beryllium to radium. When alkaline earth metals participate in chemical reactions, they follow a consistent pattern. The general equation shows a metal atom losing 2 electrons to form a metal ion with a +2 charge. This process is represented as M becomes M2+ and releases 2 electrons. All group 2 elements form ions with a +2 oxidation state by losing both of their valence electrons. An important trend to remember is that reactivity increases as you move down the group. This means calcium is more reactive than magnesium, which in turn is more reactive than beryllium. The alkaline earth metals show varying degrees of reactivity with water, following the general equation. Metal plus water produces metal hydroxide plus hydrogen gas. Beryllium is the least reactive and does not react with water or steam at all. Magnesium shows intermediate reactivity, reacting slowly with hot water but vigorously when exposed to steam. Calcium is much more reactive and readily reacts with cold water, producing bubbles of hydrogen gas. This increasing reactivity down the group is a fundamental characteristic of the alkaline earth metals. Magnesium is one of the most important alkaline earth metals with numerous practical applications. In the aerospace industry, magnesium alloys are highly valued for their lightweight properties, making them ideal for aircraft and spacecraft construction. When magnesium burns, it produces a brilliant white light, which is why it's commonly used in pyrotechnics, fireworks, and emergency flares. Biologically, magnesium is an essential mineral for human health, playing critical roles in muscle contraction and nerve function. Additionally, magnesium is increasingly used in high-performance battery technology due to its favorable electrochemical properties. Calcium is perhaps the most familiar alkaline earth metal due to its biological importance. In the human body, calcium is the essential structural component of bones and teeth, making it vital for skeletal health. In the construction industry, calcium carbonate forms the basis of cement and concrete production, literally building the foundations of modern infrastructure. Agriculture relies heavily on calcium compounds, particularly lime, which is used to reduce soil acidity and improve fertility. In metallurgy, calcium serves as a reducing agent, helping extract other metals from their ores through chemical reactions. Alkaline earth metals form many important compounds used in everyday life. Calcium carbonate, with the formula CaCO₃, is found naturally as limestone, marble, and chalk, and is also used in antacid medications. Calcium oxide, CaO, known as quicklime, is a crucial ingredient in cement production. Magnesium sulfate, MgSO₄, is commonly known as Epsom salts and has various medical applications. Calcium hydroxide, with the formula CaOH2, called slaked lime, is widely used in water treatment processes to adjust pH levels and remove impurities. Let's summarize the essential points about alkaline earth metals. First, all group 2 elements have 2 valence electrons in their outermost s orbital, which determines their chemical behavior. Second, they all form +2 ions by losing both valence electrons during chemical reactions. Third, reactivity increases down the group due to decreasing ionization energy, making it easier for larger atoms to lose their electrons. Fourth, magnesium and calcium are particularly essential for both biological processes and industrial applications. Finally, these elements form important compounds, including carbonates, oxides, and hydroxides that we encounter in daily life and industry.
If you like this video, hit that like button and don't forget to subscribe. Visit CaCO₃.com for more such useful content.